thank you so much for having your time for this sharing session. Okay, so just now Dr. Nizam already gave us my working experience. It's actually before I joined UTEM, I've been working in few companies around, not around in Johor and also in Malacca. So most of it is from the quality background. That's why for me, it is more comfortable for me to teach the quality subject instead of the material subject. My degree, my bachelor study previously, but I am more preferable to teach quality subject because for me, quality subject is more uh, because it's more realistic. We can do the calculation, we can observe, we can propose the action we want to do, and then we can measure, we can monitor whether our ideas, our action taken is good or not to solve the problem. Okay, so so today our topic is 7 QC2. I believe that everyone already if we are in the quality background or if we are on the industry, so 7 QC2 is considered a well-known item. I can say also it's as a traditional method, but even it's a traditional method, for me, it is a very valuable because it is easy to implement, easy to understand. And if we have a master or we have know what each of the what is the meaning and how to use each of these tool, it can help us to solve many defect or quality issue, or maybe also we can use in others fields such as in research or in others maybe in marketing and so on. So the QC, the 7 QC tools is actually we can say that it is talk about the how we want to collect the data from all the 7 tools. We can use it to collect the data when we have the data, so we can use also some of the tools to do the analyzing process, which means that we read the data that we have, we analyze the data, and then from that we can have the input, the information, so we can know what is the root cause, the initial problem that we have facing actually, and then we can propose the countermeasure, the ideas on how to solve or maybe to reduce the problem. Then also we can use this tool to measure whether our ideas, our countermeasure just now is good or maybe it still need improvement or not. So with these 7 basic QC tools, we can do at least these 4 types of activity in quality. Okay, so the main important is also when we talk about the 7 QC tools, it is involved on the numerical data. So which means that if we have a data in terms of numbering, so it is suitable to have the QC tools. But if you have a data not in terms of number, maybe in terms of information such as the in alphabetical or something like that, so it is not suitable to use these 7 QC tools. So if we look about the history of these 7 QC tools, is proposed by Japanese, which is Dr. Kaoru Ishikawa in 1968. Okay, so Dr. Kaoru proposed these 7 QC tools in his book, say Gemba no QC Shuho. So based on this book, propose the 7 QC tools to be used and to be practiced by the Japanese firms at that time. Okay, so sorry. Okay, so for today, what is the 7 basic QC tool we will go through is first we will talk about check sheet, okay, and then histogram, and then number 3 is a Pareto analysis. Time we can also found it called as a Pareto diagram. Number 4, the most popular, which is fishbone diagram, or some books also known as a cause and effect diagram. And then followed by scatter diagram, or also known as a scatter plot, flow chart, and control chart. So this is basic 7 QC tool was introduced by Dr. Kauru. Okay, so we can, for today, for this time, for this 1 hour, I would like to share each of these tools, what does it mean, and how we can use it in order for us to help us to solve the problem in industry. Okay, so we start with the check sheet. Okay, so even we say that, oh, that's only check sheet, it's a very simple check sheet, but okay, please don't do because for me, check sheets is a very valuable tools for us to dig information from our production line. Okay, so if you are involved in developing a check sheet, in to monitor or to check or the quality or to perform any study, so please do a proper study to develop or to create a, a very good check sheet so that we can have so much information uh, from the check sheet. So because we can easily have the information based on the check sheet if we properly design a check sheet to collect the data. Okay, so there are a few types of check sheet which is available. For example, the defect allocation check sheet, tally, the defect cost check sheet, and also the checklist. So we will take a look what each of these types of check sheet. Okay, so defect location check sheet. So this kind of check sheet is most likely to be used in industry because normally we just uh, put the diagram of our product have been produced. For example, in this figure, this is a door car, and then this is from the painting process. So the inspector, when do the inspection, so when he found a defect, he just put the sticker or maybe the sticker or just any shape to identify each of the defect on the check sheet given. So from this we can see that, oh, okay, based on the first observation already we can see that, oh, okay, so from this part, okay, most of this bubble defect at this area and also this area. So why? So it's easily for us to just make a spark of interest to know what happened, why only this and this area got so many bubble, and why are the others areas do not have any defect like a bubble for this case. So you can see that how easy we can have the information from the current production status performance of the producing the part based on the check sheet if we have this kind of check sheet. So it depends on suitable the environment, the parts of the product we produce. Okay, so the next type is frequency check sheet. So this is the most common. So when we found a problem, a defect, we just count how many, and then maybe we can put the comment to identify what kind of color, which is easily to get confused and so on. So this is we call as a frequency check sheet. And the number third is a data defect cause check sheet. So you can see what is the difference between this one and this one. Okay, so for this one is more, if we can have more information because they ask the inspector or the operator to fill up the information what kind of machine that produce. So it is more, for example, for we want to know if we have a defect problem suddenly in our production line, so we go back to the check sheet, we can see, oh, it's come from this machine number 2 and it's on the afternoon session from this operator. So it is more easily for us to traceability back. So if we have a very proper check sheet to collect the data in our production line. And the last one is the checklist. So checklist is normally we use to guide when we want to do the process or we want to do the activity, so that we do not forget any step or something like that. So that is an example of the checklist. So we can see that even it's like a simple information, it's just a check sheet, so we can have many or a lot of information, a valuable information based on the performance of our production process if we design a proper and a suitable check sheet in our for our operator, for our inspector usage in their daily work. Okay, so that is about the check sheet. Okay, the second item for this 7 QC tool is we call as a histogram. Okay, histogram. So when we have one amount of a data, okay, so kita ada satu set of the data, we have a set of a data. So from that the data, we can have the information, we can know what is actually the story behind the data if we construct or if we develop a histogram. Because histogram is developed based on a frequency. Okay, so it based on the frequency, how many times each of the data has been repeated in one set of the data. So that is a histogram. And histogram is more compared to the check sheet just now, it's not involved the calculation, but for histogram it's involved a very just have a short or a very easy calculation to perform this histogram. Okay, so from the histogram, we can analyze our production process performance by we measuring or we check where is the location of the mean and also the variation that occur in our production line. So we can see the mean value, the average or the variation that can occur in our production line based on the constructing the histogram. Okay, so how the histogram look like? So this is a common histogram. We can see that the histogram is different from the bar graph because histogram is referring to the number of range on the x-axis. Okay, compared to the bar graph is based on the category on the x-axis. Okay, so it means that when we plot the histogram, so how our histogram will look like, it will totally refer or effect or influence by our data itself. Okay. Okay, so as I said just now, we construct the histogram to monitor where are the mean value and
Maaf,
also
Dr.
to know
Yusriza,
what
maaf
is the
saya ganggu sebentar.
yeah.
Kepada siapa yang mohon mute mic.
Rasanya tak ada.
Dr. Yusriza, saya ada dengar bunyi machining dekat belakang tu. Mohon mute.
Sambil bekerja sambil menonton.
Itulah, cuma saya tak dapat cari sebab saya dah mute semua. Saya tak jumpa yang tak mute.
Maybe
Saya tak pasti.
use the handphone. Selalunya handphone kita susah nak mute.
Tak, tapi dalam list ni semua dah mute. Dalam list participant. Tu saya pun agak pelik juga. Okey, tak apa. Doktor mungkin boleh teruskan. Saya nanti check macam mana.
Okay. Okay, so back to our slide. So histogram, okay, just I said just now, we construct the histogram because we want to know where are our mean value, nilai purata, our data. So from that, we can see that is there any variation, okay, in our production line. So when we talk about variation, okay, so in quality, we always need to have a very small variation. So that is the aim in quality, because if we have a very high variation in our production line, tendency to produce the product to the customer is very high. That's why in quality and any activity we do, our aim is to reduce the variation in our production line. So one of the method we can have to see, is there any variation in our production line, so we can construct the histogram. Okay, so it's a very easy to construct a histogram. We can use Microsoft Excel to construct the histogram, but I think we have to have the Microsoft Excel with the add-in function of data collection. And also there are also a few software which is most commonly used in industry to analyze the data, such as Minitab and so on. Okay, so for how we want to construct the histogram, let's say we have data around 50 to 100 or more than that. Okay, so the first step, we have to know what is the range of our data. Okay, because histogram is talk about the range. Okay, remember the x axis and y axis is the range. Okay, so we have to determine what is the range of our data. So range means the maximum minus the minimum. So based on that, the value of the range, we can calculate the size and also the class interval, which means that how big of this bar or how big of this kotak-kotak ni, this box. So it based on the range value, because if we do not properly determine the size of this box, so sometimes it will affect the information that we will have, because if we have too big of the box, okay, maybe like this, we have too big, so we just only have a very little information. So we can say that we have to know how to calculate the size of this box. Okay, so then after that, we can perform the counting of data point based on each of the frequency just now, and then we can draw the histogram. So that is a basic step to draw the histogram. So okay, so what are the benefits and the input we can get when we draw the histogram? Okay, we can glance the variation, just I said before, because we want to reduce or minimize the variation. Okay, and then based on that also, we can also know our process behavior based on the shape of the histogram we have. Okay, based on the shape. Okay, maybe this kind of shape. For this, we have two peak, so we call it as a bimodal types of histogram, because each of the shape and the size of the histogram will help us to identify whether there is any hidden source of variation or not. Okay, so from that, when we have the information based on the data we have, so we can start the improvement, the activity to do the process improvement in our production line. Okay, so for histogram, the ideal one of histogram, they should have a bell curve lah. Bentuk macam ni kan, bell curve. And then the center of the histogram must, the value of the mean, and also it must equal to the median value. Okay, so that we consider as a stable or the the balanced histogram, or we call it as a unimodal histogram. So what are the types of common histogram? Which is, okay, let's say we have this kind of histogram. It will show, or it will give us different types of information. For example, let's say this is our data, the histogram. Okay, we have the histogram, which is most of the data, the frequency, or it repeat on this side. But our mean value is here. So we can say that our the product for today is all far from the mean value. So maybe if it go to this, is already a defect, or is already out of spec. So which means that we are in a danger condition, because our production is getting out of the control. Okay. Okay, so beside that also, this kind of histogram also can give us information that this also maybe our production process produce the product getting out of the spec on the higher position. And this kind is, okay, so we can say that production for today, they have a 3 group of the data. Some are mean at this area, some are mean as this area, and some are their mean value of data at this area. So why this kind of histogram we have? Maybe different types of operator, or maybe it's a different come from the different machine, or maybe it's come from setting of the machine got a problem, and so on. So when we develop, or when we create a histogram, we can have a lot of information from the histogram that we have construct. So yang pentingnya kita kena pandai membaca, okay, histogram yang kita buat, dan dapatkan maklumat daripada production line, apa yang berlaku sebenarnya. So that is the aim. Okay, so the third one is the Pareto analysis, or is a Pareto diagram. So I think Dr. Nizam, we have a question, I think, in the chat. Should I answer just right now or after this?
Oh, okay. Actually, both ways. It's just that I don't want to disturb your presentation, but since it's already in the topic now, so one of the question is the Minitab is a recommended software to use for SPC analysis?
Okay. Minitab. Okay. For me, Minitab is recommended because it is easy to use. Then from the Minitab, they have a lot of function. Maksudnya dia ada bahagian-bahagian yang kita boleh kira SPC, process capability and so on. So in UTEM, in my faculty especially, Fakulti Teknologi Kejuruteraan Mekanika dan Pembuatan, we subscribe this Minitab software, and then we also embed this Minitab software during our lab session in our students. So means that our student they use to do the analysis for the SPC using the conventional method, kira dengan tangan, and also they use the Minitab to do the analysis. Okay, sebab for me Minitab is quite user friendly. It's their interface of the Minitab is almost like the Excel. It's compared to others statistic software like SPSS, all that is more to the research. But for industry, if we talk about industry usage, for me, my personal experience or my personal, I suggest suitable to use the Minitab. Okay. Then
Okay.
the next question,
The next question is about just the example from previous
bimodal.
slide.
What contribute to a bimodal graph? Okay, so
Yes.
histogram bimodal, which is they have two peaks, like this just now. So they have, if we look at this histogram, we can say that Y, our data, the frequency, maksudnya kekerapan data kita tu banyak berulang di point ni dengan point ni. So where is our mean value based on our spec from our customer. So spec of our customer, where is the mean value? So we can say that what is happened? Maybe 2 times adjusting the setting of the machine or something like that. So there, if you ask me what is the contribute, so it depends backs on what is your scenario of your production line. If you involve about the setting machine ke, so it may be because of 2 times setting a different machine, or maybe changing the materials or something like that. So that the factor that contribute to this kind of bimodal too, it depends on your industry. It depends on your surrounding of your industry punya area. Okay.
I think there is a lot of question regarding the Minitab and also the bimodal. The next question is that is Minitab can be used to perform, I think this is DOE, the design of experiment analysis?
Boleh. Kan? Minitab boleh. Boleh. Minitab boleh.
And okay, and another question, shift change is possible to create this bimodal peak?
Shift changes, maybe, because when we have a shift change, means that operator bertukar, maybe when change the operator, they have do the different setting of the machine, it may contribute. But kita kena siasat, kena selidik. I can say that mungkin yes, because different industry different. Then we can use this 7 QC tools to perform the investigation, to perform the analysis, to find out what is the root cause actually contribute to the problem.
Okay, thank you, Dr. Yusuza. You can continue with your presentation.
Okay, so okay, almost halfway. So Pareto diagram, Pareto analysis. Okay, so even Pareto was introduced by Dr. Kauru, but it's actually developed by Juren. Okay, so this is Europe guy, okay, in 1950. Okay, so what is the difference between Pareto and other types of graph is Pareto rank the data. Rank, which means that they are sorting the data from the highest to the lowest. So that is a Pareto. The graph will show you rank of the data. What does it mean by the rank? Which is it's sort ataupun dia dia susun the data from highest to the lowest. Okay, and sometimes, okay, Pareto analysis, they come with this, we call it as a cumulative line. Okay, so Pareto, they have a y-axis, they have 2, which is here. This is our data, and this is referred to the cumulative line axis. Okay, so the most common we heard when we do the Pareto analysis is 80-20 rules. Okay, 80-20 rules. So what does it means by 80-20 rules? Okay, it means that nampak tak geram? So this is 80%, right? This is 80%. So okay, so we can say that if we look at this graph, okay, actually 80% of the most contribute defect or problem in this case is only this 3. Is only these 3 defect. Okay, so means that if we can solve these 3, okay, we can solve 80% of our problem with work effort of 20%. So that is 80-20 rules. Okay. Okay, so ni I dah cakap tadi. Okay, so when we have a cumulative line, so we found where is the 80%. So here, so we can say that this type of defect contribute 80% of the total problem. So when we focus to solve only these 3, which means that we already solve almost of our problem with the effort of work of only 20%. Itu maksudnya 80-20. Okay. Okay, so how to construct the Pareto diagram? So because we say that Pareto diagram is the rank, so first step to do when we have a lot of data, we have to do the sorting lah, rank lah. Okay, and then after that, okay, so we sort the data based on the rank, highest to the lowest, and then we calculate the percentage each of the defect we have. Okay, then we also, because we want to have the cumulative cumulative line like this, so we have to determine the cumulative percentage. Okay, so how to calculate? So this one, okay, yang ni akan dapat ini campur dengan ni lah. Macam tu lah. So it's just, if we have the Excel already, kita dah boleh buat template siap-siap. So any problem, ada any new data yang we want to analyze, we want to investigate, we just can put in the we can put in the our Excel. Okay, so this is example of the Pareto diagram or Pareto chart. Okay, so basically the Pareto chart we can use when we have a few types of defect or problem, which is we don't know which one is contribute more problem to us. So we can know that, we can sort that when we do the Pareto analysis, because dia buat konsep 80-20 tadi kan. Okay, so that is the benefit or the usage of the Pareto diagram. Okay, number 4 is a fishbone diagram. Okay. Okay, so it's also introduced by Dr. Koru. So just now, yang Encik Adam asked me, the bimodal, is it possible come from shift changing ke? What is the possible that contribute to the problem? Encik Adam can use this fishbone diagram to help you to identify what is the possible source ataupun what is the root cause that create the problem yang Encik Adam facing itu. Okay, so fishbone diagram also can show us what the relationship for each of the effect yang kita fikirkan. Okay, so pada dia punya diagram. Tengok pada dia punya. Okay, so why they call fishbone diagram? Ataupun some dia panggil Ishikawa diagram because introduced by Koru Ishikawa just now. And then why they call fishbone? Because it look like ada fish lah, ada kepala, ini dia punya apa tulang-tulang dia kan. Okay, so that's why they call as a fishbone. Okay, so commonly, fishbone diagram. So when you have a problem, so you write your problem here and then you try to brainstorming with your team to identify what is the root cause of the problem if we think based on the materials side, for example, like that. So basically, this is a guideline. We can separate or we can categorize our fishbone diagram based on the material, method, machine, measurement, personnel, environment. But this is not fixed like this. So you can change based on your environment situation at your industry. So I don't say that you must use this kind, this is fixed or no. So we can change based on our requirement suitable in our process. Okay, so basically people we use this to ensure that there is no missing when we do the brainstorming process. So we can have perform a team so that each of us can contribute the ideas, what may be what is the may be the root cause of the problem based on each of these category. So this is a fishbone diagram. Okay, so fishbone diagram, when we want to clarify, to identify what is the cause and what is the effect. Okay, so effect ni problem lah. Okay, so we can use this fishbone diagram because after we have one complete of diagram, we can clarify which is the most contribute to that problem. So from that also we can listkan, yang mana yang paling critical, the most critical, so that we can take the necessary action, the countermeasure based on the root cause that we have been identified in our fishbone diagram. Okay, so that is number 4. So now we move to the QC tools number 5, which is scatter diagram. Okay, so let's see, we have in our production line, we have a data with maybe 2 variables or maybe 3 variables. So we don't know what is the relationship between this data. So the most easiest way to see is we perform the we construct the scatter diagram. Okay, for example, we have a data with 2 variable x, variable y. So what is the relationship between these 2 variable? So the easiest way to see, is there any correlation ataupun apa hubungan antara dua data tersebut? So we perform a scatter diagram. Okay, so basically, from the scatter diagram, if we have construct a scatter diagram, we can make a conclusion whether our data have a positive correlation or negative correlation like this, or maybe no correlation at all. So we can say that the scatter diagram can help us to identify what is actually the strength or the factor or the relationship between the 2 variable that we have. Maybe is that the cause and effect information from that, or any others relevant information from our data. So saya rasa yang ni ada contoh. So let's take care of this example. For example, this is the ice cream shop. So they collect the data based on the daily temperature and the sales. okay, the daily temperature and the sales they have. If they are not perform any graphical visualize data, maksudnya tak buat graph, tak buat apa, based only refer to this, tak ada siapa pun boleh bagi conclusion apa perkaitan, what is the relationship between temperature and sales. But if we perform the scatter diagram, because we have two variable, temperature and sales. So let's say if we perform the scatter diagram, so we can say that, oh, we can say that we have a positive correlation. Means that our sales getting higher when the temperature is high. So make it visualize, okay? Make it visualize is more easy to interpret the data, okay? So that is the usage of the scatter diagram. So rather than we have only this kind of data in form of the numbers, so why don't we visualize it? So bila kita visualize kan jadi bentuk macam ni, so it's easily to interpret, okay? Oh, we have a positive correlation. When the temperature higher, so our sales also getting increased. Macam tu. Okay, so this is the example of how to use the scatter diagram. Okay, number 6 is a flow chart. Okay, so flow chart also is another part of the 7 QC tools. So basically, we always use this flow chart to show the flow of our product or service. So step by step, so that we are not missing out or left one of the important process in our industry or in our procedure or so on. So it's more easy to understand how the process will go based on the flow chart. So flow chart will help us to easy visualize on our entire system. So it is advisable each of the process to have their own flow chart, so that from the flow chart that we have construct, so we can know, oh, where is the critical, where is the bottleneck of our process, what is always the common problem contribute by which process, so we can easily pinpoint to the actual step or actual process station, which station or contribute to the problem if we have a flow chart. Okay, so even though we look at a simple flow chart, but it's a very important tools to show that we are properly arranging our process. Okay, so to construct a flow chart, okay, we have to use the specific toolbox, okay, to make it standardized, so that we know, okay, what should is this critical process or not. So commonly it been identified by the types of the toolbox we use. Okay, specials about the flowchart is recognized, or it is have one main major function in ISO documentation. Okay, so if we go to the ISO site, when we want to construct the flowchart, each of these toolbox, whether it's square, a diamond, a round shape, will define what is the meaning. Okay, for example, if a diamond shape is referring to the inspection, there must be a result come up from this process. So it's more standardized, so that people can easily, okay, so okay, this is process is what kind of toolbox we have to put. So to make it standardized, easy to be interpret. So this is for the flow chart. Okay, and then I think, okay, the last one is a control chart. Okay, So control chart also is involve the calculation. Same like the histogram, scatter diagram, Pareto diagram, and control chart also involve a calculation to construct it. Okay, so the reason we perform the control chart because we want to check our process condition, whether it's stable or not, whether it's under control or not, to know whether our process is under control or out of control. So we have to perform the control chart. So in control chart, there will have a central line, upper line, and upper control limit, and also lower control limit. So this is the basic item that must have in the control chart. They must have a central line, upper control limit, and lower control limit. So when we can use this control chart, we want to control our process. We want to predict, is there any expected changes will occur. Also, we can do based on the control chart. So we also can use this control chart to check whether our project to do the improvement, is it perform well, is it function or not. So we can also use the control chart to monitor our project that we have proposed to do. Okay, so that is for the control chart. So the basic procedure to construct a control chart, first you have to choose the suitable control chart based on the data you have, because we have a few types of control chart. So it's not we can simply choose, I want to use this one. No, you have to choose the right control chart based on the types of the data that you have. Okay, then after that you have to perform the you have to determine the control line just now, and then you have to collect the data. After that, when you collect the data, you can see whether is there any out of control or not from your data. So this is the basic control chart. Like I mentioned just now, they have a central line here. They have a upper control limit and lower control limit here. So this is the data that you are collecting. Okay, so you can see whether your performance, your process performance, is it okay or not based on the control chart that you have already construct. Okay, so basically we can use the control chart to see that is there any problem in our production line. Okay, for example, after you construct a control chart, you see that your data is like this. Why it suddenly increase going upward? So you have to look back at your production line. Is there any something happen? Why the data is consecutively increase? Okay, and also why is increase but in the steady trend? Just now is significant increase, or why is recurring? Sekejap naik, sekejap turun, sekejap naik. So we can see we can have a lot of information once we construct a control chart. Ataupun we can see that our data have two population. So all this will give us many meanings what is actually happen in our production line. Okay, so this is the usefulness of the constructing a control chart in our production line. Okay, so like I said just now, you can't simply use any types of control chart that you are prefer. No, you have to choose the correct control chart based on the type of the data that you have, because we have, this is the basic, and we have around 7 types of control chart. So how to use which one? is suitable with your production line. So it based on
Dr. Yusriza,
here.
there is a question in the chat. How to
Okay.
determine the UCL and LCL?
Okay. Encik Sarizam. There is a formula to calculate the upper control limit and lower control limit, Encik Sarizam. I I tak share dalam slide ni sebab because it's only 1 hour kan. Kalau I nak share calculation tu nanti jadi panjang pula. Tapi kalau Encik Sarizam berminat nak tahu formula dia, Encik Sarizam boleh email saya tak? I share my email in the slide just now. Okay, nanti I will share you the formula on how to calculate the upper control limit and lower control limit. Boleh? Okay. So how to choose the suitable the correct control chart is based on your types of data you have. First, you have to know whether your data is attribute or variable. So kena tahu beza dulu. So let's say you are from your data from your production line is variable. So kalau dia variable, so how many sample size you collect? Okay, how many sample size? Is it more than 10? Is it less than 10? If more than 10, you can use this X bar S. S is for the standard deviation. But if you less than 10, you can use X bar R. R is for range. Okay, so that is variable. Let's say if you have your production, you are collecting the data in your production line is attribute data. Attribute just based on the counting. Let's say from the 100 pieces you do the inspection, 10 is defect. So that is a attribute data. So from that, so you can divide, okay, whether it's a defect or defective. Okay, so this is a different meaning on that. So which one is suitable so that you can choose whether you can use P chart, NP, C or U. Okay. Ada soalan? What is the difference between variable and attribute data? So variable data is data you get from the measurement process. Okay, measurement process means that, for example, length, panjang, kan, thickness, sebab ukur kan, measure, you ukur, okay, temperature, because you use the thermometer or thermocouple to check. So that is a variable data, data based on the measurement process. You have the data based on the measurement process. So you collect the information based on the, for example, your data is the length. So you collect the information, you collect the data length, okay, 11.10 cm, 11.5 cm. So that is a variable data. So attribute data is data you get from the counting process. Okay, so means that, like for example, your operator do the sampling process, he pick 100 piece of sample, okay, and then he performed the inspection. From the inspection, he said that, okay, 8 is defect. And they count kan, 8 is defect. So this is a attribute data. Okay. I dah jawab soalan tu, Cik Dr. Nizam.
Ya.
Okay. So that is basic 7 QC tools. So kita ada sikit masa lagi, so kita tengok example, okay, case study on how to use the 7 QC tool. Let's say this industry produce bicycle, okay, so they found that they have a defect such as corrosion, scratch, incorrect hole alignment, dent, well, macam-macam. They have a lot of types of defect they're facing. So they want to do the process improvement or quality improvement to reduce all these defects. So okay, so what they can do first, sebab they have a lot types of defect yang dia sendiri pun tak tahu yang mana sebenarnya contribute more actually to their problem. So they have to identify the problem so they can use the Pareto diagram. So they use the Pareto diagram, 80-20 here. So he can say that actually dia punya problem only this. if this company can solve this portion, so means that they can solve their quality problem. Okay, so this is the example. First, they can use the Pareto chart to prioritize what is the main crucial activity they need to focus. Okay. Next, when they know already what is the main defect that contribute to the problem, dia dah dapat dah puncanya, so they want to collect the data, so they can use fishbone diagram to get the information, to do the analysis. Okay, they can to collect the information from their members, from the production line, and so on. They can use fishbone diagram, for example. Okay. Okay, so when they got the information, they also want to do the analysis. They can use histogram, they can use the scatter diagram, because it can visualize what is actually correlation data and so on that they have. They can have more input information from that. Okay, so they can use scatter diagram, histogram to do the analysis of their problem, and then they can propose the countermeasure for. So in this case, they propose the countermeasure based on each of the bone fish tadi. Okay, dia okay katalah A1 problem. So what is the countermeasure? So they are suggesting each of the problem, each bone of the problem with countermeasure itself. Okay, then they perform, they implement the countermeasure, and then to monitor, to check whether it's accomplished or not. So they can use the control chart, or maybe can use also the histogram to verify the action taken, whether it's good or not, whether they can reduce or not the defect. So this is easy example to show how to use these 7 basic QC tools when we have a problem in production line, in producing the product or process. Okay, so I think that's all for me. Thank you so much for your participation.